A round pencil rolls off a desk at a 2-degree tilt. A hexagonal one sits still on a 15-degree slope. That single geometric decision has saved more half-finished drawings and unsigned checks than any other design choice in the history of stationery. Here's what you're actually going to learn. Why the hexagon won over the circle, the cylinder, and even the triangle. Why the wood species matters as much as the shape. Why one country still makes round pencils on purpose. And why the manufacturing process behind that 6-sided form is far stranger than you'd expect. Most people assume pencils are hexagonal because it's comfortable to hold. And sure, flat sides do give your fingers something to grip. But that's not why it happened. The hexagon wasn't chosen by an ergonomics consultant. It was chosen by factory engineers in the mid-1800s who had a very specific problem. Pencils kept destroying themselves during production. Before the modern pencil existed, writing sticks were round. Round felt natural. Round looks like a branch, and the earliest pencils were literally just graphite rods wrapped in string or stuffed into hollow reeds. When Caspar Faber set up what became the first industrial pencil factory in Stein, Germany in 1761, the machinery he used was adapted from lathe work. Round was the default. It's what lathes produce. But round pencils had a catastrophic flaw that only showed up at scale. Here's the core mechanical problem. When you mill a pencil, you're gluing 2 grooved slats of wood around a graphite core, then running that sandwich through a shaping machine. If the cross-section is circular, the slat can rotate slightly during the glue cure. Even a 2-degree rotation misaligns the core. The graphite ends up off-center. When you sharpen the pencil, you hit graphite on one side before the other. The tip snaps. At a factory running tens of thousands of units a day, a 5% breakage rate is a financial disaster. The hexagon solved this mechanically. 6 flat faces mean the 2 halves of the wood slat register against each other with 0 rotational freedom. They key together like a nut and bolt. The core stays centered within a fraction of a millimeter. Tip breakage dropped dramatically. Faber-Castell, by the late 1800s, had standardized on the hexagonal form not because of how it felt in a hand, but because it made their production line stop wasting wood, graphite, and time. The ergonomic benefit was a side effect. A welcome one, but still a side effect. Now here's the counterexample that proves the rule. Staedtler, also German, produces the Mars Lumograph in a round barrel. Art supply stores carry them. Ask any technical illustrator and they'll defend the round form. It rolls smoothly in your fingers when you rotate the pencil while drawing long lines, maintaining a consistent point. Round pencils are better for that specific motion. Staedtler can get away with manufacturing them because the Lumograph is a premium product made in lower volumes with tighter quality control. They accept a higher per-unit cost to serve a professional niche. That's a viable business at low volume. It was not viable for Faber in 1880 when he needed to ship 1 million pencils a month to schools across Europe. The wood choice reinforces the hexagonal geometry in a way most people never consider. The dominant species used in pencil manufacturing is incense cedar, Chalocedrus decurrens, grown primarily in California and Oregon. This wood has a specific property. It sharpens cleanly without splintering. The grain is tight and consistent. But incense cedar also machines best when the shaping blade meets a flat face rather than a curved one. A hexagonal cross-section means the milling cutter hits flat grain repeatedly, in predictable increments, rather than continuously engaging curved grain. The tool wears more evenly. The surface finish is cleaner. The wood and the geometry are co-evolved, not just historically matched. This gets even more specific. The standard pencil hex is not arbitrary in its dimensions. A typical pencil is 7 millimeters across the flats, which is the distance between 2 parallel faces. That dimension was arrived at because it fits comfortably between an adult thumb and 2 fingers without requiring a pinch grip, and because it allows a wall thickness of roughly 2.5 millimeters around a 2 millimeter graphite core. Go thinner, and the wood cracks when you sharpen it. Go thicker, and you're wasting incense cedar, which by the 1990s had become expensive enough that manufacturers started blending it with Chinese basswood to cut costs. Now, when does the hexagon fail? In cold weather, in the hands of children under about 8 years old. A hexagonal barrel on a small hand concentrates pressure at the corner edges of the faces. Kids who grip hard end up with red ridges on their fingers. That's why Staedtler's Wopex, introduced in 2011, went triangular. 3 faces, larger flat areas, softer compound outer layer. Triangular pencils had actually existed since the 1960s in Europe for early childhood education, but they never crossed into general production because they're harder to manufacture in the cedar slat system. The Wopex sidesteps that by using an extruded plastic wood composite rather than traditional slat construction. It works, but it feels wrong to most adults. The surface has a faint rubbery drag that confuses the hand. The same hexagonal logic shows up in places you'd recognize immediately once you see it. Hex bolts and nuts use the 6-face geometry for the same anti-rotation reason as pencils. A wrench needs flat faces to grip, and 6 faces give you the smallest rotation increment before the next face is available, only 60 degrees. Hex keys, Allen wrenches, the barrels of certain fountain pens, some cigar shapes. Whenever a manufacturer needs rotational stability plus a surface the hand can register against, the hexagon keeps winning. It is the shape of controlled grip. A round pencil is a natural object. A hexagonal pencil is an engineered one. That 6-sided form carries 2 centuries of industrial logic inside it. The Faber production line, the incense cedar grain, the 7mm flat-to-flat measurement that fits an adult hand without being designed for it. Every time a pencil stays on your desk instead of rolling to the floor, that's not luck. That's geometry doing its job. If this is your kind of thing, the why behind everyday objects. Object Theory drops new ones Monday, Wednesday, and Friday.